Here are my 3 solar arrays I have in my backyard, 9 panels each. They have a 2-axis tracking system. As far as the structure goes, there's 9 240-watt panels, and they're connected to 9 N-phase M250 microinverters. Most of the structure I used unistrut on. The base is a poured concrete circle with a lip around it. The purpose of the lip is to have something to grab underneath in case the wind happens to take it for some reason. There's a wheel on this one underneath and on top. And there's just a bar underneath the 2 sides. It rotates on a bolt in the middle. And there's a wheel here, wheel here, wheel here, and then the drive wheel is over here. The drive system is a Ford truck windshield wiper motor, and it's 12 volts is what I needed, and it's already geared down somewhat. I had to gear reduce it down even more to give it enough torque to turn the whole thing. This is the drive in motion. Moves pretty slowly. That's what you want. The tilt pivoting is accomplished with a 12 volt 24-inch linear actuator. Right now this one's all the way down at the bottom because the sun's pretty low in the sky. It's near the end of the day. These linear actuators are rated for 600 pounds of push, which is plenty for this. As far as the control system goes, this is the brains behind it. There's a 12 volt power supply, an Arduino Uno board, some 5 volt relays, 12 volt relays, and on-off switch to provide power to the Arduino board, and manual switches for left and right and up and down. One other thing, there's a real-time clock, so the system knows what time of day it is. The Arduino board measures the voltage of those the small sensor solar panels up at the top, and fires the relays accordingly. There's an up, down, left, right 5 volt relay, and those switch 12 volts to these heavier duty relays down here that control the left and right and up and down. Alright, here's how the sensors work. There's a very small solar panel right here. There's one on the other side. And then there's a divider in between them. The Arduino board measures the voltage of this one and compares it to the voltage on the other side. And if one's generating more voltage than the other, it means the sun's that direction, and it turns it accordingly. This is the one that controls left and right. And there's one down there that does up and down. Same thing, just as the small solar panels on the top and the bottom. On the high voltage end of things, there's 2 electrical connections. One of them, the small one down here, is 110 volts that feeds the 12 volt DC power supply and the control system to keep everything there running. And the other large cable, the one right here, that's 220 volts that is wired off the inverters. That's what feeds electricity back into the house. There's 3 limit switches on each one of the arrays. The top limit switch, one right here, is an overall limit switch for if it goes too far one way or the other. One of the stops is right there, and there's another one over on the other side. If for some reason the thing freaks out or starts to move too much, it gets moved too far, then it'll hit that limit switch, and the limit switch is wired in series to the Arduino board. So if this limit switch is tripped, it kills the power of the Arduino board and everything comes to a stop, just for safety. We can't have this thing spinning around with the high voltage wires that are going up to it. The other 2 limit switches are used to reposition it at night. Every night I have it reposition itself so it's facing south in the morning. One reason for that is if it's facing south, then it can pick up the morning sun to reposition itself automatically. If it was left facing the west where the sun sets, then the sensors wouldn't be able to pick up the morning sun when it rises. Another reason is if it's a cloudy day, the solar panels will still generate a halfway decent amount of electricity as long as they're pointed south. So what I have it do is, since I don't know where it was left during the day, because it could have been, we could have had a sunny morning and then around noontime this got cloudy, and it doesn't track when it's cloudy. So I'm not sure where the system would be when the end of the day arrives. So what I do is I have it rotate clockwise until it hits this stop, which is right near the maximum stop. And once it hits that, it triggers it in reverse and goes back until it hits this stop over here, which makes it point south. And then everything comes to a complete stop until morning. If for some reason we expect bad weather like a hurricane or a tropical storm, I live in Florida, what I've done to help prepare for that is, as I already mentioned, the lip around the concrete holds everything down. And my thinking is, if there is a big storm coming, I'll take the whole array, lay it down flat. I'll make that linear actuator go out until the whole array is flat. And then when I poured the concrete base, I poured loops in all the way around. So I'll tie it down to there. If it's supposed to be really bad, then it wouldn't be that much of a deal to actually lay the whole thing flat and then just unbolt the panels and put them in the shed for the time being.